Hi guys, welcome to inverse trig function. So in this video we're going to explore inverse sine, inverse cosine, and inverse tangent, as well as solve out two triangles using these inverse trig functions. So we're going to talk about exactly what are inverse trig functions versus, well, why can't we just use regular sine, regular cosine, and regular tangent all the time? And how do we use them, and then we'll go into some examples because who doesn't love examples? So what exactly are these inverse trig functions? Well, they are exactly that. They're the inverses of the trig functions we hold near and dear, sine, cosine, and tangent. The main difference is, though, in regular sine, cosine, and tangent, right, we input a theta. That's a theta. We input an angle, and we output a ratio. Right? We do sine of 30 degrees, we do sine of 90 degrees, we do sine of 135 degrees. We input an angle and it outputs us the ratio. The ratio that it outputs us, in particular, is the opposite over the hypotenuse, right? But what does the inverse do? Well, it does what every inverse does. It switches the inputs and the outputs. So the input of inverse sine is a ratio, and the output now is theta, or an angle. So it does the opposite, right? Same thing with cosine, same thing with tangent. So why do these help us? Well, we don't always have the exact amount of information in right triangles that we would like, even though in a perfect scenario we would only need to use sine, cosine, and tangent, but sometimes we can't, unfortunately. So these inverse functions help us to solve when we have a different set of information given to us and we still need to solve out the whole right triangle. So instead of talking about it, let me just show you an example, like so. So solving the right triangle, again, means finding all angles and finding all sides. Well, what do we know? Well, we know that angle is 90, we know that side's 8, and we know the hypotenuse side is 11. Now, how could I find the other side? Well, I have a couple options. I can use inverse trig, or I could use Pythagorean theorem because we're in a right triangle. But with the theme of the video, I'm going to use inverse trig. So what side is this in relationship to my angle x? Well, it's touching, and it's not the hypotenuse, so it's the adjacent side. So I can say cosine of x is equal to my adjacent side, call this A, is equal to my adjacent side over my hypotenuse side, right? Okay, well, does this help me? Oh no, there's more than one unknown. I have x and I have a. Okay, so scrap that. This actually isn't going to help. This may happen to you guys a couple different times when you're solving these right triangles. If you don't set it up correctly and you have too many unknowns, you're not going to be able to figure it out. So cosine of x is not the thing that I want because there's too much unknown information. So what should I have done instead? Well, I have the opposite side and I have the hypotenuse, so what I should have done instead is in fact take sine of x, because sine of x is equal to the opposite side, which is 8, over the hypotenuse side, which is 11. Now I only have one variable floating around. So if you get in a situation like I first did and you have two variables, back up, maybe try a different trig function that only gives you one unknown. Okay, so anyway, from here, well, how do I solve this out? Well, I have sine of x. How do I get rid of the sine? Well, let's use our best friends that we just learned about, inverse trig. Oh, that doesn't really show up too much over there. Let me use yellow. Let's use inverse trig, right? What does a function its inverse do? It kind of cancels each other out there. So we're left with just x on the left, on the right. Now we have inverse sine of 8 over 11. Shove this into your calculator, and we shall get inverse sine of 8 divided by 11. 46.7, I'll call that. 46.7. So x is 46.7. How could I find this angle here? Well, that's just 180 minus 90 minus 46.7. So what is 180 minus 90 minus 46.7? That'll give us 43.3. Right, because 180 degrees in a triangle, so I can find that angle. Okay, so now the only thing on my triangle that's missing is this side here. Well, how could I find that side? I could use Pythagorean theorem, or I could use trig. Let's just keep using our trig function since that's what we're here for. Let's see. Let's use this angle here, and A would be opposite. So sine of 43.3 is equal to my opposite, which is A, over my hypotenuse, which is 11. Now I don't need to use inverse trig here because I'm already good. Times both sides by 11, times both sides by 11. Those 11s will cancel out. On my right side, I'll just have A. On my left side, I'll have whatever 11 times sine of 43.3 is, which would give me 7.5. 7.5. 7.5. Now my triangle is completely solved. I have all angles and all sides. Alright, let's see another example. And this example is going to be a little harder, so we're going to really kind of bolster it up now. And this is going to be the last example we're going to do. Alright, how do we do this? Find the lengths of the missing sides if side A is opposite angle A, side B is opposite angle B, and side C is the hypotenuse. Oh dear. Okay. Always, 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 if it's not given to you, draw the picture. Let's say that's capital A, let's say that's capital B, which means that that's lowercase a, which means that's lowercase b, and the hypotenuse is lowercase c. And we got a right angle in there. So we're good. Okay. Let's see, cosine B is 5/13. So how could I get angle B? Oh, I could use inverse trig, right? Because I could get rid of that cosine. So I could have B equals inverse cosine now of 5/13, and that will give me angle B. So angle B is equal to, what is inverse cosine exactly? Of 5 divided by 13? Well, that is 67.4. 67.4. So B is 67.4. Oh, and we're actually even given A. So that is 15. By unknown side A, we know you're 15. Okay, how could we find capital A? Well, 180 minus 67.4 minus 90. 180 minus 90 minus 67.4, 22.6. So angle A is 22.6. Okay, now I need to find lengths B and C. Well, how could I do that? Well, I'm going to use this angle here, and I'm going to use my opposite, and I'm going to use my adjacent. So who is opposite and adjacent? Well, tangent is. So tangent of 22.6 will give me the opposite side, which is 15, over the adjacent side, which is B. Now I solve for B, so I'm going to end up with B is equal to 15 over the tangent of 22.6 by algebra. So B is going to be equal to 15 divided by tan of 22.6, 36. So side B is 36, and I'm rounding. Now to find side C, we could use Pythagorean theorem, but I'm going to stick with the trig. So there's many different things that you could do here. I'm going to use this angle again, and I'm going to use opposite over hypotenuse. So that would bring me to sine 22.6 equals opposite, which is 15, over hypotenuse, which is C, which I don't know. So if I do some algebra, I will end up with C is equal to 15 over sine of 22.6. So side C is equal to 15 divided by sine of 22.6, 39. So C is equal to 39. And we're done. We solved the whole triangle. So if you guys have any questions, please don't hesitate to ask. You guys know where to find me. If anything was unclear, please say something. I'd be happy to help. So as always, I hope that facilitated some understanding of inverse trig functions, and I will see you guys in the next video.